For these examples, we're going to look at the law of detachment and later on the law of syllogism. I'm going to start off with the law of detachment. And just to give you a shorthand way of writing law of detachment, we start out with a basic if-then statement. Remember in the last section I talked about if P then Q, or P implies Q. My second statement will be an example where P is true. My conclusion for all of the law of detachments will be an example where Q is true. So in these examples, they're going to give you the if-then statement. They're going to give you an example where P is true, and you're going to want to write that last statement where Q is true. So for this first example, if we look carefully, our if part, or our hypothesis, is two segments having the same length. My conclusion will be they're congruent. We know that this is true, and that's an example where P is true. So my conclusion in this case would be that since they have the same length, which is shown here, we can state that BC with a bar is congruent to XY, again, with a bar. Now, for this next one, we have to be careful because it's not written as an if-then statement. We have to figure out what my hypothesis and what my conclusion is. What comes before the conclusion. So in this case, going to the movies depends on if it's Friday or Saturday night. So being Friday or Saturday night would be my hypothesis. My conclusion would be going to the movies. So you could rewrite this as, if it's Friday or Saturday night, then Mary goes to the movies. You wouldn't write it the other way around. If she was going to the movies, then it's Friday or Saturday night. Doesn't really make much sense. We have an example here of P being true. So in other words, if it's Friday or Saturday night, well, it's Friday. So P is true here. My conclusion would be Mary goes to the movies. I guess you could say tonight. Oops, sorry. Because it's Friday. So that's our final, our Q is true there. So again, and there's a typo on this, so I'll just fix it. Basically, it's saying, because this satisfies the hypothesis, my conclusion should be that those are congruent. And for the second one, we need to identify the hypothesis and conclusion. The hypothesis is if it's Friday or Saturday night. The conclusion is she goes to the movies. Today is Friday. Satisfies the hypothesis. The conclusion is Mary will go to the movies tonight. For this next one, we're going to use law of syllogism, which we use a lot in proofs, which we'll learn about later. The basic structure of the law of syllogism, we start out with an if-then statement where P is the hypothesis and Q is the conclusion. Then we take this conclusion and we move it to our new hypothesis and come up with a new conclusion. Our final statement will be that the first hypothesis leads to the last conclusion. So again, for these problems, they're going to give you this, and you need to figure out how to write the final one. So in this first example, Rick takes chemistry this year is my P, and Jesse, being Rick's lab partner, will be my Q. If you notice, the second statement, or the second part of this, is now the first part of the second sentence. So this is my Q, but my Q implies R here. So again, we have P implies Q and Q implies R. My final statement will be if Rick takes chemistry this year, Oops. If Rick takes chemistry this year, then, and I'm getting there, then we conclude with our R, which is Rick will get an A in chemistry. Okay. For this next one, it's a little bit tricky. If we look, you want to say this is P and then this is Q, but then this isn't Q. So if we look carefully, these are actually written in a different order. We would say P implies Q, whoops, implies Q, and then this would be my Q again, and that implies R. My final statement for this would be if X is greater than 5, which is my P, and then my R here is then X squared is greater than 20. Okay? For the last one, let's see. This one doesn't look like it works so well because we've got a P here and we've got a P here. So this one shouldn't actually work because if we've got the P in the same place, then it's not truly a law of syllogisms. Even if it says so on the slides, that this isn't necessarily true. So let's take a look. For the first one again, it all matches. The statement would be, if Rick takes chemistry, then Rick will get an A. For the next one, we notice that it matches up, and we would say the first part leads to the last part. And for this last one, it says neither statement's conclusion is the same as the other's hypotenuse or hypothesis. Therefore, in this case, we cannot use the law of syllogism. Again, going back, if you notice, this P and is the same as this P, so it's not written in a form where we can use law of syllogism. Therefore, we can't write a final statement. Okay? Alright, now let's take a look here. And I'm going to go a bit quicker here. If R is in between 90 and 180, then R is obtuse. This is an example where the measure of angle R is 155, which is in between these two. So we have if this, then it's obtuse. The conclusion we can make, since this is P is true, would be that R is obtuse. Okay, here's another one. If Janelle gets a job, then she can afford a car. If she can afford a car, then she will drive to school. The conclusion we can make here, because we have P implies Q and Q implies R, we can therefore say if Janelle gets a job, then she will drive to school. So it should look like something like that. Alright, so here's ones where we just have to state the law of logic. If we look at this first one, if you get an A or better on your math test, then you can go to the movies. If you go to the movies, then you can watch your favorite actor. The next statement would be, if you get an A or better on your math test, then you can watch your favorite actor, and that would be an example of law of syllogism. So there it is. Here we have one where if x is greater than 12, then x plus 9 is greater than 20. And here we have the value of x is 14. So in that case, since that is a number that's bigger than 12, we can state our conclusion, which is x plus 9 is greater than 20. This is law of detachment. And that's it. Thanks.